Welcome to this video. So in this video, we're going to learn about statistics, particularly descriptive statistics, because we have inference, we can do inferences, or we can do relations, or we can have hypothesis testings. So, but in this case, we're going to see descriptive statistics. So as an introduction, we want to know what is statistics. So the statistics is the intersection between statistics and probability. That's the current statistics, because we need to describe, summarize, interpret, and analyze the data. So we need to draw conclusions about the data. We want to do generalization. So we know something and we can do an analysis for a piece of a population. The name is sample. We can analyze that sample, and then we can create generalizations for the entire population of that type. So that's the main goal of the statistics. So statistics in research is really important because it helps to state test the hypothesis, also make theories, or it can help to prove with all the evidence that we have, so we can make assumptions or statements. It's really important in different fields. For example, to understand how the personality is related to decision making, the risk factors for infant mortality, migration patterns, identify people who may be interested in a certain product. So we can use a statistic for different fields in research. It's important now when we're going to start working with data. So we're collecting the data, we're going to create that data sets. So, and we need to know how we're going to organize the data. It's important to know that we're going to have the variables like as columns. All the variables will be here. And then each one of our instances or each one of our observations will be in a different row. So that's the organization, the main organization of a data set. So it's important to understand this portion, because maybe in other cases we were organizing different, but in this case, each one of the instance should be in a different row. I will be showing how we're going to use a software to analyze this data. So for that reason, it's important to work like this, but also you can use Excel or other softwares. They're very useful to analyze the data. So here are just like a very brief terminology. So we know that what we're going to the units on which we measure data, such as person, cars, animals, we're called that observations or instances. So each one of our observations. Then the collection of all the units is called population. So all these observations will be the population. But if we consider just a portion of that population, we call that sample. And, use a sample, it's practical, it's cheaper, and we are reducing the time, working with just like a representative sample of that population. And the observations, the variables, and all the analysis and all the features that we're observing, so we're going to call that variables. We have different types of variables. I will be very, very brief on this portion because it's like an entire topic. But when we're talking variables, we're talking about qualitative variables and quantitative variables. So the qualitative variables are describing some characteristics of features of the sample or of the observations. So like the color of the eyes, and we use more like a linguistic, we're providing like linguistic options for each one of them. Color of the eye, name of a political party, and the transport used to travel to work. So these are the qualitative variables. And we have quantitative variables, which they are measurements, they are numbers, but pay attention here, because in some cases, qualitative variables are using numbers. But it doesn't mean that if you're using a number, it doesn't mean that you can do an operation with it. For example, how the satisfaction of a student in a course. So maybe you are rating the course with 5, but it doesn't mean that you can do a multiplication with that 5, you can do a division with that 5, because it's not a number. It's representing in a scale. We're using numbers to represent that, but it's not a number. I mean, it's not a measure what you can use to do different operations, math operations. And when we're talking quantitative variables, we can do operations like the size of shoes, price of houses, time, maybe the weight of a person, the height of a person. So that's a number that you can use, and you can do math operations. So this is like the organization. So we have qualitative variables. We can use nominal, ordinal, or we can have quantitative variables, discrete, continuous variables. And what is the difference between discrete and continuous? So discrete are variables which can only take a finite number of values, the size of the shoes, number of semesters. But then when we're talking about the continuous variables, they're variables that can take infinitive numbers of variables, and we call them continuous variables. For example, here, the height of a person. So are you sure that it's 175 centimeters? Or it should be 175.3. So that's something that we need to consider. So if you cannot, the weight, the height, the time, they are variables that we cannot know exactly what was the measure. We cannot know. We have an infinitive number of points between 175 and 175.1. We have infinitive numbers between that two numbers. So for that reason, it's continuous. So we're using scales to, maybe to cut that values and to have like something that we can work with. Yes, but the nature of that variables are discrete or continuous or qualitative. In some cases, we group the data so we can create like the frequency tables. And with that group of data, we can know how many times someone were selecting the number 5. That you were strongly agree on the satisfaction of a course. The students were, all the students are here. How many students were selecting this one? Maybe 10, maybe 12, maybe 20. And then we have another portion where we can, the students were just agree. How many of them? So you're grouping the data, and we can organize the data in frequency tables, or we can do different things with them. So this is like another representation of what we were talking. Now we need to talk about the data collection. So you will have qualitative variables or quantitative variables depending on the way that you were collecting the data. If it was a survey, so if it's an opinion, obviously it will be qualitative. If it's an experiment, that obviously will be depending on the way that you were measuring the variables. Observational data, primary and secondary data, interviews, surveys, so observations, ethnography. So that's all the types of data collection that we have. So when we're grouping the data again, so you need to define the frequency tables, how many elements, and you can send percentage for them. So it depends, right? So we have to represent the frequency tables or the frequency on the data. We use bar charts like this. So we have females, males, females, males. And then in this simple tool, you can see it and you can observe the frequencies of each one of them. So that's one option. The same can be represented in pie charts. They are always used to represent, frequencies. But if you want to represent a continuous variable, you have to use histogram. So with the histogram, you will have like a different, it's some kind of, maybe you are thinking that it's a bar chart, but it's not. So it's different because we're like for continuous data, maybe we're using all the X will be having the values that you're representing. And then on the Y, maybe you have time, or in the other case, you have time. And then on the other portion, you're representing the frequency of that element, but it's not the same. Histogram are for continuous variables, bar charts are for discrete variables or qualitative data. And then we have the measures of central tendency. So these are the functions that describe how we can rate the minimum, the maximum, the mean, the median, the mode. So what is the mean? You know, the mean is like the average of the data. The median is the value that it's once you have all the elements or just sorted all the elements, then the value at the middle, that will be the median. Then the mode is the value that it's more, that have more frequency. And then the range, you know, is the difference between the maximum, subtraction, the minimum. So that will be, and the central tendency, mean, median, and mode, they are some kind of at the middle of the curve, as you observe here, because for that reason, it's the central tendency. I mean, you cannot have values like the mean was 1, and then the median is 5, and then the mode is 7. That's not possible. That won't be a central tendency. Central tendency means that everything is really close, maybe 1, 2, and maybe 1.5. So something like that you can have. Then we have the mean, as I was saying, it's just the average, you know, it's the summation of all the values and then the division of the amount of values that you have. So we're going to do this with a software, so you don't need to worry about to do the operation with your hands or your mind. So this is the example that we're going to represent in the software. So this is the median and quantile. So what is that? The medians and the quantiles. So the median is the value of the element, you know, when you are sorting all the observations, the 50% exactly the middle, that will be the median. But then we can have also another 3 quantiles. So we are like having different pieces in our data. For example, here with this box plot, what is this? So we have all this is our data. This is the middle of the data. This is the middle quartile. So this is the median, right? But then we can do like other cuts, and then we can have different 4 quantiles. And these are representing the 25%, then the 50%, 75, and then the 100. So that will be we were talking about the central tendency, the measures of central tendency. Then another important element of the descriptive analysis are the measures of dispersion. What is that? The measures of dispersions are representing how each one of our values or data are the variability considering the mean. So, you know, for example, in this case, the green line is the mean, right? That was the average of this dog's height. So this is very tall. This is some kind of tall. These 3 are small. So we have the green line is the mean, and then we're noticing here that 147. I think that will be millimeters. This is the variability for the dogs, for each one of them, according to the mean. But, you know, the mean was calculated or considering all the heights of each one of these dogs. So that's the very important, because we can know if something is varying a lot or if something is consistent. You know, if we are considering maybe for our students in a school, maybe we want to know the age, so we can know that we have like maybe everything is the dispersion could be something like I don't know, 1 year. So we know, and the average is 25. So we know that we have students between 26, 24, right? So that will be the dispersion. And for this dispersion, we have variance and we have a standard deviation. So the variance, it's at the square of the values, but then the standard deviation is just the root square. So here is the standard. This is the variance. So as you can see, it's up to 2, And then if you want to calculate the standard deviation, you only need to calculate the, you need to cancel this doing the root square. And that will be calculating the standard deviation, which is the most common to present on any data. Okay, so all these are just the descriptive analysis, and the descriptive analysis is really, really important because it's going to describe our data. It's like summarizing what we were doing with our data.